Go.
Hey Dr. Zhang, so this is our second video project and we're gonna test the hydrostatic principle. And to do that, I'm gonna measure head pressure using some pipe, a pressure gauge, and good old trusty water. So I'm gonna fill the pipe up with water and we're gonna measure the pressure at the bottom, and we know the pressure at the top is 1 atmosphere, or in gauge pressure terms it's really 0. And so we can measure the pressure head difference like that. All right, so we are filling up our pressure gauge right here, and whenever it gets to the top, we're going to turn the water off. It's about to overflow any second now. All right, so this thing is full, so now let's go read the pressure. Okay, so our pressure is about 4.5 we're going to read. So we got 4.5 psi, and that's what we're going to use. So here's the work for the fluids. So we have our pipe up here, and we're going to make the bottom of the pipe 0 height and the top of the pipe the total height. So from the gauge to the top it was 9 foot 11 inches, and we filled it to the top with water. We have our equation for piezometric head, which comes straight from the hydrostatic principle. And here we have our readings. So the pressure of the gauge at the top is 0 psi, because that's just atmospheric pressure. Pressure of the gauge at the bottom was 4.5 psi, which is actually 648 psf. And then the height converted to feet, and the gamma of water in pounds per foot cubed. We plug everything in, and we see that the pressure that the gauge measured was a little bit higher than the height, which means that our gauge wasn't the most accurate. You know, there's a little bit of human error in that reading, and it wasn't a digital gauge, so we couldn't get an exact value, and that's kind of the big problem we had. But otherwise, it's a really close number and verifies that this all works. So, see you next time, Dr. Zhang.